Hello everyone, this is the crash course on the topics system of particles and rotational motion and one more topic, that is gravitation. Okay, so it's just a refreshing course on this topic and it helps you to face the competitive exams. Okay, so start the first question. Let us start the first question. So the moment of inertia of flying wheel having the kinetic energy 360 joule and angular speed 20 radian per second. Okay, so the given term first, kinetic energy. So its formula is half r omega square, and they are given the value of kinetic energy. This is 360 joule is equal to 1 by 2 as it is. Moment of inertia we don't know, which we want to find here, and they are given the angular speed, that is 20 square. So 360 into 2. So and here it is r into 20 square. This is 400. So 720 divided by 400 is equal to I. So I is equal to 720. Okay, 720 divided by 4. And the final answer. Is 1.8 kg meter square. So this is the option A. And the next question. In absence of external torque for a body revolving about an axis, which quantity remains constant? Okay, so here they said tau is equal to 0, and the options are potentiality, kinetic energy, linear momentum, and angular momentum. Okay, so we don't have any relation with the linear momentum with respect to the torque, but we have the relation between the torque and angular momentum, that is tau is equal to dl by dt is equal to 0 if the tau is equal to 0. So what's the tau? Is a differentiation of angular momentum. L is the angular momentum, differential angular momentum is 0, means the differentiating term which you wanted to differentiate, it is 0, it is constant. So L is equal to constant. What's the L here? Angular momentum. So the option fourth, angular momentum, is correct. Okay, the next question. A wheel whose moment of inertia is 2 kg meter square has initial angular velocity 50 radian per second, a constant torque of 50 newton meter acts on the wheel. Estimate the time in which the wheel is accelerated to 80 radian per second. Okay, what are given terms? So they are given the moment of inertia of that wheel 2 kg meter square. Okay, and they are given the initial angular velocity. Angular velocity means omega. For the initial, I have written omega naught, and its value is 50 radian per second. 50 radian per second. Okay, and a constant torque. So an external torque is acted on that wheel, and its value is 10 newton meter. Okay, so as a result of this external torque, the velocity, the angular velocity changed to 80 radian per second. 80 radian per second. If so, estimate the time in which it is accelerated to 80. So to reach the 80 radian, so initially it was 50, to reach the 80, how much time it takes? So this is our question. Okay, by having a formula, so kinetic equation for rotational motion, that is omega is equal to omega naught plus alpha t. It is same as that of v equal to v naught plus a into t. V is equal to v naught plus 80. This is okay. Was omega here? The final value 80. Initial value 50 plus alpha value we don't know. T value we don't know. So to calculate the value of alpha, they have given the 2 kg meter square. So what is that? It is moment of inertia. Okay, and given the tau. So we know tau is equal to I into alpha. And you can compare each and every equation of rotational motion with the linear motion. So we are having F equal to ma. So instead of that we are having tau is equal to I alpha. Okay, and we want the value of alpha. So alpha is equal to torque divided by moment of inertia. So the value of torque is 10. The value of moment of inertia, this is 2. So alpha is equal to 5 radian per second square. That is 5. Okay, now we can substitute the value of 5 here. So value of alpha, which is 5. Okay, and then 80 minus 50, this is 30, and 5t. Then t is equal to 30 divided by 5. So t is equal to 6 seconds. So this is our answer. Okay, here the option number 2 is the answer. that is 6 seconds. Question number 5. A circular disc rolls down an inclined plane. The ratio of rotational kinetic energy to the total kinetic energy is, okay, so there is an inclined plane, okay, and there is a circular disc. There is a circular disc and it is rolling down along this inclined plane. Okay, so here while it is rolling down, it is having the two kinetic energy. One is the rotational kinetic energy. So in addition to the rotation, it is covering the linear distance. That's why it is also having the linear kinetic energy. So the formula for linear kinetic energy. So you are very familiar with this one. This is 1 by 2 mv square. And for the rotational kinetic energy, so Kr is equal to 1 by 2 I omega square. 1 by 2 I omega square. Okay. So they are saying it is a circular disc. So by this we can get this moment of inertia. And what's the moment of inertia for circular disc? This is m r square by 2. Alright, this is m r square by 2. Okay, and omega value. We know the relation v is equal to r into omega. I want the value of omega. This will be v by r. Okay, substitute this value. Kr is equal to 1 by 2. This is m r square by 2 into omega. Instead of omega, I'll write v by r, and square term that's v square by r square. So capital R. Okay, now this r square and this r square cancel. So Kr is equal to 1 over 2 into 2, 4 mv square. This is rotational kinetic energy. I want the total kinetic energy now. So I call this is KT. This is organized completely. K total. So that will be KL plus KR. What's the KL? This is half mv square. What's the KR? Rotation. This is 1 by 4 of mv square. Okay. So 1 by 2 plus 1 by 4. 1 by 2 plus 1 by 4 and mv square is common. Now we will get 3 by 4 mv square. Okay, this is rotational kinetic energy. Is clear? And the ratio of k rotational to the k of total is equal to. So what's the rotational kinetic energy? This is 3 by 4 m. This is total energy kT. Okay, so the total energy k of t, k of r divided by k of t. What's the k of r? This is 1 by 4 mv square. And what about the total? This is 3 by 4 mv square. Okay, and the ratio 1 by 4 mv square, 3 by 4 mv square. Okay, 4 cancel. The answer is 1 by 3. So option 2. This is the answer. Okay, next one. Question number 6. If the radius of Earth contract 2% and its mass remains same, then the weight of a body at the surface is. It's very simple. Weight of the body. So the formula W is equal to m into g, mass into acceleration to gravity. So whatever be the place, so the mass remains constant. Okay. So as the r contracts, so what's the formula for the g first? So this is gm divided by r square. Acceleration to gravity on the surface is gm by r square. Is it? Okay. So if r decreased, contract means r value ಕಡಿಮೆ ಆಗ್ತದೆ ಇಲ್ಲಿ. earth ಕಡಿಮೆ, earth size ಕಡಿಮೆ ಆಯ್ತು ಅಂದ್ರೆ ಅದರ ರೇಡಿಯಸ್ ಕಡಿಮೆ ಆಗ್ತದೆ. As the radius decreases, his acceleration due to gravity increases. As acceleration due to gravity increases, what about the weight? Weight also increases because weight is directly proportional to acceleration due to gravity. Okay, I can give the relation W proportional to G, inversely proportional to R square. So as R shrinks, means R decreases, the G increases. As the G increases, the weight increases. So what's the answer now? This is option number 2. The weight will increase on the surface if the radius decreases. Okay, the next question. See here. Okay, question number 7. A thin wire of length L and mass m is bent in the form of semicircle as shown in the figure. What will be its moment of inertia about an axis joining its free ends? Okay, so the wire and it is bent in the form of a semicircle, and we started to rotate it about an axis, so which connects those two free ends. Okay, and here it is like a half ring. It's like a half ring. So we know the moment of inertia for a ring about an axis passing through its diameter. So this is m r square divided by 2. m r square divided by 2 is the moment of inertia of a ring. Okay, so we want to calculate this one. So we need the value of r. So we don't know the value of r, but we know the circumference of this semicircle. Circumference of the semicircle. So I write this is length. So the length is acting as the half of circumference of semicircle. So for a circumference it is 2 pi r. If it is a complete circle, so it is half. That's why it is simply pi r. Then r is equal to now. So now r is equal to L divided by pi. I'll take this is r. Okay, r equal to L by pi. So then moment of inertia I is equal to m as it is. So what's the value of r? R value is L divided by pi. L by pi whole square divided by 2. So I is equal to m L square and the denominator pi square and 2. So the answer is m L square divided by 2 pi square. The option number 4 is our answer. Option number 4 is the answer. M L square by 2 pi square. Okay, next one. Two planets are at a mean distance d1 and d2 from the sun, and their frequencies are n1 and n2 respectively. What's the frequency? The number of rotations in a given time interval. Okay, that is n1 and n2. Right? If so which of the following relation holds good? And we know the Kepler's third law. So that is t square is proportional to r cube. The square of time period of a planet is directly proportional to cube of its same major axis. Okay, so and it is directly proportional to the distance. The same major axis is directly proportional to distance. Okay, now I will write t square divided by r cube is equal to constant. So t1 square divided by r1 cube is equal to, so the same relation holds good for the second planet also, and those two equal. The ratio of the square of time period to the cube of its same major axis is same for all the planet. Okay, next one. So this thing is a time period. They have given n1 and n2. What are the n1 and n2? n1 and n2 are frequencies. So what the relation of the frequency with the time period? We know t is equal to 1 by f or 1 by n. Here they have given the symbol n as a frequency. So instead of writing t1, I will write 1 by n. Okay, that will be 1 divided by r1 cube as it is. So instead of t1, I will write n1 square. And here instead of t2, I will write n2 and its square. Then r2 cube. Okay, then cross multiplication r2 cube n2 square is equal to r1 cube n1 square, and see which is the correct option. Okay, option number 1. So n2 square d2 cube. n2 square d2 cube. Okay, we should alter one more thing. Instead of the r, they are taking the distance d. So instead of r, I will write d. So that is d1 cube n2 d1 cube, sorry, d2 cube n2 square and d1 cube n2 square. So the option first. So this is the correct answer. Next one. The maximum and the minimum distance of a comet from the sun are 8 into 10 to the power 12 meter and 1.6 into 10 to the power 12 meter. Maximum distance is 8 into 10 to the power 12. Minimum distance is 1.6 into 10 to the power 12. If its velocity when nearest to the sun is 60 meter per second, and what will be its velocity in meter per second when it is farthest? Okay, so comet means comet. Okay, so it is revolving around the sun and its closest distance like this. So this is the sun, it is revolving like this. So it is the closest distance. I call this as first position, and this is the largest distance. I call this as second position. Okay, the closest distance, that is 1.6 meter. 1.6 into 10 to the power 12, and the largest distance, that is 8 into 10 to the power 12. Right? And the velocity at the nearest position, this is 60 meter per second. I call this is v1. So v2 is equal to question mark. V2 is equal to question mark. Okay, how to solve this one? So for any body in its particular rotational motion, so it maintains the constant angular momentum, and that's Kepler's second law. The statement of Kepler's second law is this one only. The angular momentum of a planet revolving around the sun is constant. Okay, so comet is also revolving around the sun, so it is maintaining a constant angular momentum. I'll write L1 is equal to L2 is angular momentum at this position and this position. I'll write M into V1 R1. Here it is mass doesn't vary, so this is V2 into R2. Okay, what are the R here? So R is the distance from the sun. Okay, M cancel. So V1 into R1, V2 into R2. Okay, what's the V1 value? So for first this is 60. And what is the R1? What's the R1? R1, the closest distance. This is 1.6 into 10 to the power 8. So what's the V2? We have to calculate this one. Okay, at the larger distance, what's the velocity? What's the R2? So this is 8 into 10 to the power 12. Is it? Okay, and the next point. Say 60 into 1.6. So instead of that, I'll write 6. I'll take this 10 here. I can write 60 as 6 into 10. So I'll take this 10 here with the 1.6. This becomes 16. And 10 to the power 12. 10 to the power 12 divided by this, take this 8 here, 8 into 10 to the power 12, and the remaining term is V2. 10 to the power 12, 10 to the power 12 cancel. 6 ones are 6. Sorry, 8 ones are 8 ones are. Okay, 6 into 2. This is V2 is equal to 12 meter per second. V2 is equal to 12 meter per second. Option 3. Option 3, which is 12. Okay. The next question. If a particle of mass m is thrown upward from the surface of Earth with a velocity u, so it is thrown with the velocity u, the mass and radius of the Earth respectively are m and capital R is a full point. Next, g is the gravitational constant and small g is acceleration to gravity on the surface of Earth. Estimate the minimum value of u, estimate the minimum value of speed, so that the particle doesn't return back to the Earth. It means we should calculate the initial velocity or initial speed with which it is thrown, so that it never returns to the Earth. For that we call it as a escape speed. We call that as a escape speed, and we know the formula for escape speed. And for escape speed, now they have given the symbol as u, escape speed. For this question, it is u. Usually we write it as ve, and the formula is you can write 2gm divided by r. 2gm divided by r. So this is our formula. So they are asking the same thing. What is the value of initial? What should be the value of initial speed so that the body never returns to the Earth? Is nothing but the escape speed value. So that is 2gm by r. So option 2. Root of 2gm by r. This is the correct answer. You may confuse the option 2gr square. It may be right. So because we write the escape speed in terms of gr, so small g also, that will be root of 2gr. But here the term is square, so it may confuse you. So go to the option 2, root of 2gm by r. Next question. Right. The center of mass of a triangle, as shown in the figure, has coordinates. Okay, so we should get the coordinates of center of mass. So if you want to get the coordinates of center of mass, first we should get where the center of mass. Okay, and this is x-axis and this is y-axis. And for this distance from here to here, so this is h value. Okay, so I'll write this is h, and from here to here this is b. Okay, so to solve this one, I assume there are 3 particles of equal masses. 3 particles of equal masses at the corners of the triangle. Okay, so now I say this is first particle, this is second particle, and this is third particle. Okay, so what's the position vector of the first particle? Position vector of first particle. So what are the coordinates here? So here it is the origin. I take this is 0, 0. 0, 0. So I write 0i plus 0j. So for R2, so this is the second one. So it is having the x value and y value is 0. So I write bi cap plus 0j cap. And for R3 body, for R3 particle, it is having the y value but 0 along x axis. So 0i plus hj. Is it? Okay. So what we want here? We want the center of coordinates of center of mass. So I write r of cm is equal to, we know the formula m1 r1 plus m2 r2 plus m3 r3 with the vector notations divided by m1 plus m2 plus m3. Okay, substitute this value, and I already told you by assuming the particles are of equal masses. So I write m1 equal to m2 equal to m3 equal to simply m. So I will write m and all the mass terms. Okay, next RCM is equal to the first term m1 into r1. R1 value is completely 0, so no need to write this one. So this is 0, and m2 into r2. m2 value is m. R2 value, see here, R2 equal to b into b I cap, and 0 term, no need to write this one, plus m3 into r3. m3 value is m. m1 equal to m2 equal to m3, r equal to the m only. So r3 value is, so no x coordinate, so there will be y coordinate j. So m into h j cap divided by m1 value m, m2 value m, m3 value m. So this is m plus m, this is 3m. Okay, so here the next one, RCM is equal to m into b I cap plus m into h j cap divided by 3m. Take the m common here. Take the m common in the numerator. There will be b I cap h j cap divided by 3m. Now m get cancelled. So here this will be b I cap h j cap divided by 3. So you can also write it as b by 3 I cap plus h by 3 j cap. Okay, so what are the coordinates? B by 3 and h by 3. B by 3 along x axis and h by 3 along y axis. So the center of mass is having the coordinates b by 3 and h by 3. Option 1 is correct. Next one. So is a statement. There are two statements. Statement 1. Torque is equal to rate of change of angular momentum. Obviously, torque is equal to rate of change of angular momentum. Yes, it is correct. So tau is equal to dl by dt. Correct. Okay. Second one. Angular momentum depends upon the moment of inertia as well as angular velocity. Moment of inertia as well as angular velocity. L is equal to I omega. Moment of inertia and angular velocity. So the statement 1 is correct and statement 2 is also correct. Okay. Then which of the options is correct? Okay. So option number 2. Both the statement 1 and statement 2 are true, but the statement 2 is not a correct explanation of statement 1. So both are correct, but they don't have any relation between them. So that's why we have to go for the second option. Even though they are true, both the statements are correct, but they are irrelative. Okay, second statement is not a explanation of the first one. Is it? So that's why the option 2. Next question. Okay, 3 rings have the mass m and radius r arranged as shown in the figure. The moment of inertia of the system about y dash. See here, this is the one ring and the ring, second ring and third ring. Okay, for the first ring, so I'll write here. So this is first ring, this is second ring and third ring. This is y and y dash axis. So with about this axis, all that entire system is rotating. Okay. For the first one, we can say the moment of inertia about an axis passing through its diameter. So that will be 1 by 2 m r square. Okay. See the diagram. That will be 1 by 2 m r square. 1 by 2 m r square. And for the second and third, so what about this axis of rotation? So that will be tangent parallel to the diameter. Diameter ಗೆ parallel ಆಗಿದೆ ಹಿಂಗೆ. Diameter ಗೆ parallel ಆಗಿದೆ. So for this case, we know the formula. That will be 3 by 2 m r square. 3 by 2 m r square. And third one, for this also, it is tangential. The tangential axis, it is the axis of rotation, and it is parallel to the diameter. That is 3 by 2 m r square. 3 by 2 m r square. So the total moment of inertia is equal to I1 plus I2 plus I3. So next I is equal to, so this is 1 by 2 m r square, and next one is 3 by 2 m r square, and third one it is also 3 by 2 m r square. Okay, so m r square is common term and the denominator is 2. Okay, so then 1 plus 3 plus 3. So finally, this is 7 by 2 m r square. So this is the moment of inertia of the entire system. Option first is correct. Next question. The moment of inertia of a thin square plate ABCD of uniform thickness about an axis passing through the center O and perpendicular to the plane. So it's very important word here, and that is a clue to solve this one. Okay, and see here, this is the first axis, this is second axis, third axis, and fourth axis. They are given the names 1, 2, 3, 4 for those axes. Okay, we know the perpendicular axis theorem. So what's the perpendicular axis theorem? The moment of inertia about a perpendicular axis. For example, this is. So if it is a plane perpendicular to that plane, so this is the perpendicular axis now. The moment of inertia about a perpendicular axis is equal to the sum of moment of inertia. The sum of moment of inertia about the coplanar perpendicular axis. For example, so this is the z axis, and this is x axis, and this is y axis. If you want to get a moment of inertia along the z axis, which is perpendicular to both the y and x, so you write ix and iy. Iz, which is perpendicular to ix and y, is equal to sum of the remaining two mutually perpendicular coplanar axis. So y and x, they are in same plane. Z is perpendicular, so that's why the sum of these two is equal to the moment of inertia along the perpendicular axis. Okay, if so, and here this is I3. Sorry, third axis, and this is the fourth axis. This is the fourth axis. Okay, and see, both are perpendicular to each other. If you want to get a moment of inertia perpendicular to this plane, so that will be the sum of moment of inertia about the third axis and about the fourth axis. I can write I is equal to I3 plus I4. Okay, next we can take that one more pair, that is this one I1, and there's a one more, this is 2, and here this one and this one, these two are also perpendicular. I can write the moment of inertia about the perpendicular axis is equal to moment of inertia about the first axis plus moment of inertia about the second axis. These two are also perpendicular to each other. Okay, and also we can take okay, by this we can say I1 equal to I2 equal to I3 equal to I4. The sum of any two axes, the moment of inertia about the sum of moment of inertia about any two axes will be same. So moment of inertia perpendicular to this square is equal to I1 plus I3 or I3 plus I4 or I1 plus I2. All are correct. So that's why the option is all of the above. You can write the option is all of. Question number 21. The radius of planet is 1/4 of radius of Earth, and its acceleration due to gravity is double that of Earth's acceleration due to gravity. How many times will the escape velocity at the planet's surface be as compared to its value on Earth's surface? Okay, first we will see for Earth. The escape speed V is equal to root of 2gr. Okay, so in question ಕೊಟ್ಟಿದ್ದಾರೆ. So there is a one more planet. This one more planet. Its radius. I'll write RP is 1/4 of Earth radius. I have taken Earth radius as R, so the prime radius as R by 4. Okay, and they said the acceleration due to gravity on the surface of that planet is twice as that of is double that of the acceleration due to gravity of Earth. So acceleration due to gravity of Earth, I have taken this as g. So that's why for planet that will be 2g. Then escape velocity on that planet is equal to the formula 2 into acceleration due to gravity into radius. Acceleration due to gravity is 2g, or I'll write here g of p and r of p. Okay, so this is 2 into gp value. This is 2 times the acceleration due to gravity on the Earth, and r, it is 1/4 of the radius of Earth. So next 2 into 2 4, and the denominator is 4. This 4 and this one cancel. So this will be gr. So this is v of p. Is it? And we know ve is equal to root 2 gr. Okay, I can write v is equal to root 2 of root 2 into root 2 gr. Is it clear? Okay, now you can write escape speed on the earth is equal to root 2 times escape speed on the planet. So what the question here? Here we should compare the escape speed of planet with respect to the earth. So take the Vp as it is, keep the Vp as it is, and take this root to this side. This will be V by root 2. So the escape speed on the planet is 1 by root 2 times the escape speed on the earth. So you can write 1 by root 2 times the escape speed on the earth. This is the escape speed of planet. Okay, so this is the answer. Okay, which option is correct? Third one. So 1 by root 2 is the correct answer. Next, question number 23. If g is proportional to r cube instead of r square, then the relation between the time period of a satellite near the Earth's surface and radius will be. Okay, see here. In fact, the acceleration due to gravity is in inverse correlation with the radius. Okay, so if so, we are having the term the gravitational force is equal to gm into the mass of that body, mass of the Earth, and r square. So it is true. But the case here, they are saying if that g is inversely proportional to cube of that radius, so what would be the time period? What would be the time period? And what is the relation between time period and radius? Okay, in this case, we know the relation. We know the relation t and r. That is t square proportional to r cube. So these all are true. But here the situation is different. Suppose, by assuming if that g is inversely proportional to cube of the radius, okay, let us say the centripetal force of that satellite, so that should be provided by the gravitational force of that satellite, gravitational force on that satellite, okay, and this is m r square omega, okay, m r square omega, and the gravitational force is g into mass of the body, mass of satellite divided its radius cube. Why I am taking this as a cube? Because I am assuming the g is inversely proportional to cube of that radius. If so, here the gravitational force will be gm into m divided by r cube. If here, so if it is by r square, so here it is also r square. If it is r cube, here it's a r cube. Okay, let us see. Then, so m r square. Sorry, this is mv square divided by r. This is centripetal force. I want to write v value in terms of angular velocity. Why to write the angular velocity? Because we want to take the t term. Omega is equal to t pi by 2 pi by t. So what is the relation between v and angular velocity? So m as it is angular velocity. This is r omega square divided by r is equal to gmm divided by r cube. Now this mass term and the mass term cancel. Okay, here it is r square omega square divided by r square omega square divided by r equal to gm divided by r cube, gm by r cube, and here this is a r term and this is r square term. Okay, what are the remaining terms here? What are the remaining terms? So it is simple r and omega square divided by, okay, nothing. So r is cancelled, and here this is gm divided by r cube. Okay, and omega square instead of omega square, I write 2 pi by t whole square, and I take this r this side. This is gm divided by r cube is there, and one more r. This become r to the power 4. Okay, and see the denominator. Okay, this is 4 pi square divided by t square. 4 pi square divided by t square is equal to gm divided by r to the power 4. So this is the relation between t and r. So how we can write it? We can write it like t square proportional to r to the power 4 and t is proportional to r square. So this is the relation when g is inversely proportional to cube of the radius. Okay, if it was square of radius, this is our case. If it is cube of radius, this is the case. Okay, the next question. Question number 24. The mean radius of Earth is r. So this is the Earth and its radius is r. Okay, its angular speed on its own axis is omega, and the acceleration due to gravity on the surface is g. The cube of radius of orbit of geostationary satellite. Okay, so a satellite is revolving around the Earth, and I say its a radius from the center of Earth is smaller, or you can say its a distance is smaller. Okay, if Earth is moving with the angular speed omega, then the geostationary satellite also must move with the angular speed omega. Then only it becomes geostationary. Okay, and here, so what they are asking? So they are asking the cube of radius of orbit, and see the option that in terms of omega. Omega means angular speed. Okay, so what's the orbital speed first? So this is orbital speed is equal to gm divided by r. So what's r here? R is the distance of this satellite from the Earth, and capital R is radius. So instead of v, I can write r into omega. V is equal to r into omega. R into omega is equal to gm divided by r. Okay, then omega is equal to 1 by r. I took this here, 1 by r gm divided by r. Okay, then if I take r inside the square root, so what happens? So gm as it is. So if I take r inside, this is r square, and already one more r is there. So next one, omega is equal to under root gm. So instead of gm, what I can write? So instead of gm, we can write g r square. So g r square divided by r cube. Okay, then square the term. So omega square is equal to, this square root cancels, g r square divided by r cube, and rearrange the term. I want the value of the cube of radius of geostationary satellite. Geostationary satellite radius is the small r, its cube is r cube. So r cube is equal to g r square as it is divided by omega square. So this is g r square divided by omega square. This is the answer. Option number 2. Option number 2 is the correct answer. Next one. Question number 25. If the Earth is treated as a sphere of radius r and mass m, its angular momentum about the axis of rotation with the time period t. So what is the formula for angular momentum? So this is I omega. Okay, I omega. So I have taken this equation value equal to I omega because the options are in terms of m r square like this. Means m r square is something related to the moment of inertia. So moment of inertia of a solid sphere, and Earth is considered to be a solid sphere, and its value is 2 by 5 m r square. 2 by 5 m r square, and omega value, this is 2 pi by t. So L equal to I omega. I value is 2 by 5 m r square. Okay, and omega value 2 pi by t. Okay, next 2 into 2 4. 2 into 2 4 5, and this is 5. This is 5 and denominator t, and this is m r square. So this is the answer. So which one is correct? 4 pi m r square divided by 5t. 4 pi m r square divided by 5t. Option 1 is correct. Next one. If r, small r denotes the distance between the sun and the earth, then the angular momentum of earth around the sun corresponding to angular momentum of sun corresponding to, okay, so we know angular momentum is equal to mvr, and for this we I should take v naught. What the v naught is the orbital, it is the orbital speed of the earth around the sun. Okay, and we know the value of v naught. Substitute L is equal to m into gm divided by r divided by small r. It's a distance from earth to the sun. Okay, and next one. So I can write it as m as it is root of gm divided by, I write the r separately with the square root, and this is r. Okay, L is equal to m into root of gm, and here this is root of r and this is r. So this r can be written as root r into root r. Root r into root r. Among these two root r, one root r is cancelled and another root r is there. So L is directly proportional to square root of R. Is it clear? So I can write this R as root R into root R. Square root of R into square root of R. If I multiply, square root cancel and this will be R. So now this R cancel. There will be 1 root of R. So angular momentum is directly proportional to square root of R. Next question. The total kinetic energy of a rolling solid sphere is the sum of translation as well as rotational kinetic energies. Yes, it is true. Total kinetic energy is the sum of translational as well as rotational kinetic energy. Already I told you, for a rolling body there will be two kinetic energy. One is due to its rotation and another is due to its linear motion. Okay, and the second statement, it is true. First one is true. Second one, for all the bodies, the total kinetic energy is always twice the translational kinetic energy. So they are saying for all the body, the total kinetic for all the bodies, total kinetic energy is always equal to 2 times the translation kinetic energy. So it doesn't hold good for all the cases. It is possible only for the hollow cylinder. And hollow cylinder and the ring. So for ring and hollow cylinder only, the total kinetic energy will be twice of its translational kinetic energy. Okay, in remaining cases it will not be whole good. So that's why the second statement is wrong. It's not applicable for all the bodies. It's applicable only for the hollow cylinder and the ring. So which one of the options is correct? First one is true, second one is false. So statement 1 is true, but statement 2 is false. Option number 3 is correct statement. Correct one. Next one. Question number 28. 2 point objects of masses 1.5 gram and 2.5 gram respectively are at a distance of 16 centimeter apart. The center of gravity is at a distance x from the object of mass 1.5 gram where the x is. Okay. So there are two bodies. One is having a mass 1.5, another one is having the mass 2.5 gram. Okay, right. Then, so they are at a distance 16 centimeter. Then the center of gravity is at distance x from the 1.5. So this is the x distance. From here to here it is x distance. And I call this as center of gravity. What is the remaining distance? 16 minus x. The total distance is 16. So here from here to here it is x. So that's why the remaining is 16 minus x. Okay. We know at the center of gravity, the moment of both the forces are equal. So what the moment of force means? It's a force into the distance. So they are same for both the bodies. So what the force on this one? 1.5 mass into its acceleration into gravity into mass into its acceleration into the distance is x is equal to here the mass into its acceleration g into the distance is 16 minus x. Now the g and g cancel. Here it is 1.5x is equal to 2.5 into bracket 16 centimeter. So 16 minus x. Okay, so 1.5 as it is 2.5 into 16. So that will give you 40 minus 2.5 into x, that is 2.5x. Take this minus term this side. 2.5 minus it will become plus here. 2.5 plus 1.5. This is 4x equal to 40. Then x equal to this is 10 centimeter. Okay, the option is 3. It means the center of gravity is at 10 meter distance from the 1.5 gram body. Okay, next question. A wheel of radius 0.4 meter can rotate freely about its axis as shown in the figure. A string is wrapped over its ring and a mass of 4 kg is hanged. An angular acceleration of 8 radian per second square is produced in it due to the torque. So then the moment of inertia of the wheel is, okay. So initially it was rotating with the constant angular velocity. Okay. When a rope with a mass of 4 kg is applied on this wheel, so there will be a force like this with the rotational effect. So that is considered to be torque. So with this torque, it started to accelerate, and that acceleration is 8 radian per second square. If so, what's the moment of inertia? Okay, so here we should go through the torque. So we know the formula tau is equal to I alpha. Okay, and also we know tau is equal to R into F and the sin theta. So what's the theta here? Theta is the angle between R and F. So this is the R and this is the F. Applied force is downward and here it is R. The angle is 90 degrees. Sin of 90 is 1. So R into F. What do we want here? We want the value of I. So that is I is equal to R into F divided by alpha. So what's the value of R? Is the radius. Its radius. It is 0.4. And what's the applied force? This is applied force. I call this is mg. Applied force is mg divided by alpha. The again the alpha value. This is h. Is it? Okay. And the next one 0.4 as it is. M value, mass, it is 4. And the acceleration due to gravity is taken to be 10. And this is h. Is it clear? Okay. So next I can multiply the 0.4 into 10. This is 4. And one more 4 is there. So it is simpler way. 0.4 into 10, this is 4. And 4 as it is, divided by 8. This is 16 divided by 8 is equal to 2 kg meter square. It's the unit of the moment of inertia. So what we did here? We take the relation of torque with respect to the moment of inertia with respect to the force. They are given the force and they are asking to get the moment of inertia. So this is the important concept. Next one. Question number 33. A wheel having moment of inertia I value. This is 2 kg meter square about its vertical axis. Rotate at a rate of 60 rotations per minute above this axis. The torque which can stop the wheel's rotation in 1 minute would be. Okay. So what is 60 rotation per minute? It is the frequency. They are given the frequency. Okay. Frequency is 60 rotations per meter. And see this I. It is in terms of SI units. So that's why we should convert it into SI unit. It is rotation per minute. We should convert it into rotation per second. So 60 rotations per minute per second. 1 minute is seconds. These are 60 seconds. So 60 rotations in 60 seconds. And then 1 second this is 1 RPS. Was the RPS rotations per second. This is the frequency. Okay. And what they are asking? They are asking the value of torque to stop the wheel. Okay. So tau is equal to I into alpha. This is our formula. Have you given the value of alpha? No. But they are given the two values. One is F1 is equal to 1 RPS and then given F2. This is 0. Why I am taking the F2 as a 0? Because that wheel is going to stop. Okay. I will write omega 1 is equal to 2 pi F1. So this is 2 pi into F1 value is 1. This is only 2 pi. And omega 2, the final angular velocity, that will be 0. Because it is going to stop. So the final position is at rest. Omega 2 is 0. So value of alpha, that is final minus initial angular velocity divided by t. Okay, final value is 0 minus initial value is 2 pi divided by time. T is they said it stops in 1 minute. So 1 minute means 60 seconds. So the answer is minus 2 pi divided by 60. Minus 2 pi divided by 60. Is it? Okay, and the next step, tau is equal to I value, this is 2, okay, and alpha value, minus 2 pi by 60, I can write it as minus pi by 30. So 2, and here it is, we can cancel 2 and 60, this is pi by 30 with the negative rotation. So now, 2 and 30, we can write minus pi divided by 15, this is our answer. And here in our options there is no negative term, so they are asking the magnitude of torque. So why have got the negative sign here? Because it is a retarding torque. So it is opposing torque. It is going to, this torque is stopping the motion. So it is opposite torque to that rotational motion. That's why the negative sign. We neglect. So you neglect that sign and go for the magnitude. That is pi by 15. Option number 2. Pi by 15 Newton meter. Okay. Next question. If the Earth shrinks such that its mass doesn't change but radius decreases to 1/4 of its original value, then one complete day will be. Okay, so when the radius of Earth is r, I take this r1 is r, then the time for one day, so it is in terms of hours. See the option there in terms of hours, so I will take this as 24 hours. 24 hours when the radius is r. And see, they have said if the Earth shrinks such that its radius changes to, I said this is r2, it is changed to quarter of its original value. I said it's r by 4. Okay, so then what should be? The duration for one day. Okay, so we can solve this by using the conservation of angular momentum. Okay, so initially I said this is I1 omega 1 and this is I2 into omega 2. Okay, so what's the I? I is the moment of inertia and Earth is considered to be a sphere. It is a sphere, so that's why it's a solid sphere. So solid sphere, that's why its moment of inertia. Its moment of inertia is 2 by 5 m r square. The moment of inertia is 2 by 5 m r square. Okay, so see here for first one 2 by 5 as it is, mass doesn't change as it is. So initially its radius was r. So moment of inertia is 2 by 5 m r square. And what about the omega 1? I write this is 2 pi by t1. 2 pi divided by t1 is equal to I2 value. So I2 is the same thing, 2 by 5 mass as it is, and the radius changes from r to r by 4, and this term is in square. And what about the omega 2? So omega is 2 pi, so t2. So if this thing, the radius change, the time changes. So this is, so next term, so 2 by 5 cancel, m cancel. So the remaining term here, this is r square, and this 2 pi cancel, r square divided by t1, r square by t1 here, and here r square divided by 4 square, r square divided by 4 square means 16 into 2 pi cancel, and here this is t2. Now r square cancel. So take this t2 here, cross multiplication, and t1 numerator divided by 16. And we know the time period of Earth when its radius is r. So we take it as 24 hours and divided by 16. If you simplify, we will get an answer. We will get an answer 1.5. So T2 is equal to 1.5 hours. So what is this? If the radius is shrinks to 1/4 of its original value, then the duration for a day that will be 1.5 hours instead of 24 hours. Okay. And the next question. Question number 37. Checking the radius of Earth to be 6,400, r equal to 6,400 kilometer. By what percentage? They are given a blank there. So by what percentage will the acceleration because of gravity at a height 100 km from the surface of Earth differ from that on the surface of Earth? So question ಏನಂದ್ರೆ Earth radius 6,400 ಇದೆ. So ಇವಾಗ acceleration due to gravity 100 km ಇದ್ದಾಗ ಎಷ್ಟು ಇರ್ತದ? If you compare that acceleration due to gravity at 100 km with the acceleration due to gravity on the surface, so what should be in percentage wise? Should calculate this one. So we know the acceleration due to gravity at a height h is equal to g into gh is equal to gm divided by r plus h whole square. This is our formula. Acceleration due to gravity at a height is equal to gm divided by r plus h whole square. Or you can write gh is equal to, instead of gm I can write gr square divided by r plus h whole square. Okay, so this is the formula for acceleration due to gravity at a height h, and substitute the values. So g as it is, and R value 6400 whole square divided by 6400 plus one more 100. What is this 100? The height, the given height 100. So it's a square term. So GH is equal to G into bracket 6400 divided by 6400 plus 100. This 6500 and whole square. Two term numerator denominator square alidava. Okay, so we can write the GH is equal to Z into 64 divided by 65 whole square. Right? So I have to calculate the percentage change. So we can calculate the change in acceleration to gravity. Change in acceleration to gravity. So that is delta G is equal to G minus GH. So why I written G minus GH? Because it is the maximum value on the surface, and as we go above the surface, it decreases. So maximum value, minimum value. I want the percentage change, not a change in accelerating. I want percentage change. So that is delta G divided by original G into 100. So the same thing, G minus GH divided by G into 100. Okay, is equal to. So G as it is minus GH value. So this is G into bracket 64 divided by 65 whole square divided by G into 100. Okay, then here I can take the G outside from the numerator, and the remaining term is 1 minus 64 divided by 65, and the denominator G as it is. This G cancel and square. Okay, one sec, sorry. So this is square. Right. So what's the thing now? 1 minus 64 divided by 65 whole square. Okay. So if you simplify this one, we'll get an answer. Okay. See here. So what happened? G as it is. So if I take G outside, so it is 1 minus 64 divided by 65 whole square. Okay. Divided by G into 100. Now G cancel. So the remaining term is 1 minus 64 divided by 65 whole square. 64 by 65 whole square. If you and into 100. So if you simplify this, so you get an answer nearly 3. So this is 3%. So the option is fourth one, about 3%. Okay. Next, you try to solve the remaining questions. If you have any doubt, you call to my personal number.